Well, hello everyone, and welcome to the first video in a set of lectures that is geared towards making you understand the fundamentals of calculus. Now, let me tell you a little bit about this course in itself. This course is, of course, it's on the topic of calculus. More importantly, this is geared towards students in class 11 and class 12. For the context of this course, I'm going to be referring to the syllabus in Indian boards. And because of this reason, this course is ideally suited for students in class 11 and 12, especially those studying in India. Although I would like to mention that there is a possibility that younger students could also understand this course, provided that they have exposure to both algebra and trigonometry. Moving on, and let me also take this opportunity to tell you about myself. That's me right there, and I'm a second year MBA student. I am an engineering graduate with a major in computer science, and the main reason for me doing this is because I absolutely love math, and I've always believed that mathematics has to be taught a certain way, and this is my attempt at doing that with you. Let me then move swiftly on to the topic for today's video as well, and that is the idea of calculus. Right, let's get started. Now, the fundamental premise of calculus is that it is used to model the change in behavior of something. In that sense, you could call calculus a mathematical study of change. Now, how this exactly means pertains to change is something that we will see in the next few lectures. But for now, this context should be enough. Besides this context, I think it's important to give you some historical context as well. And calculus in itself was discovered by Sir Isaac Newton and Leibniz in the 17th century. Now, both of these men are jointly the discoverer of calculus, and there's some controversy about who was the first to do it. But for now, we'll just assume that the both of them jointly discovered it. About the question about why you should be studying calculus, I think it's in some sense a tool. Just as in elementary school, you learn arithmetic to understand basic operations like adding, multiplying, subtracting, deducting. And in middle school, you learn algebra to map unknowns and model them in mathematical language. Like x becomes an unknown because of algebra. In that same sense, calculus allows you to model and represent change of anything. Now, the change of the behavior of any variable can be modeled using calculus, and how that actually happens is something that we'll see in the next few lectures. Moving on to the first topic of today, it's limits. Now, right, so before we begin a formalized study of what limits are, let's make a very quick revision down memory lane to what functions are. These functions are going to be something that are essential in understanding how limits behave. And for the purposes of this module at least, we can look at functions as nothing more than little black boxes. Something, some concept or some construct that takes in some value and gives you another value out. You give an x and you get a value f of x. This is at heart the concept that drives the logic of functions. Now, take for example the following function. The function f of x is equal to x plus 13, where x is equal to 17. Now, 17 goes into this equation, modifies it, and the answer is 30. Here x is equal to 17 and f of x is equal to 30. Fair and simple, isn't it? Moving on to the next concept then, that while these functions could become as complex as possible, but they can always be thought of as these little black boxes, taking in one value and giving out another. Now, to take one more example, consider the following function. F of x is equal to sine x plus cos x. What would be the value of this function at pi by 2? Why don't you take a second and pause this video and work this out before getting the answer. Right, so when pi by 2 goes in, we see that f of x is equal to sine pi by 2 plus cos pi by 2. You know, sine pi by 2 is equal to 1, cos pi by 2 is equal to 0, and f of x is equal to 1. Now, knowing that, let's do a very quick exercise on the same concept that we studied. Could you find out the value of the following functions provided? Now, if you have difficulty in understanding what these functions are, please feel free to pause the video and note them down. After noting them down, should you have any conceptual understanding, that is missing in figuring out the answer, look and think of these functions as the black boxes that I just described, wherein there's a function f of x is equal to 3x plus 9. 3 goes in and replaces x. What will be the value of f of x? For the last question, it helps to think of it as two variables, a function that is based on two variables. Knowing this, I'd like you to take a moment and work out the answers for this. Pause the video and unpause it when you have all the answers and we can go over them. Right, the answers follow to this. Now for the purpose of these answers, I've taken pi is equal to 22 by 7. It's alright if you haven't taken that and have instead worked them out on a calculator taking the more accurate value. Just make sure the values are close by. So for the 5 questions that we described, the answers are as follows. f of x is equal to 18 when x is equal to 3, and so on and so forth. Please do verify that these answers match. If they don't, please leave a comment below and I'll be happy to look into why you didn't get the answer that was required. Moving on to the next topic then. Now this is exactly what limits are. Limits are basically the answer to the question, when x tends to a certain value, what does f of x become? When x approaches a particular value, what does f of x become? Now this word tends to, x tends to something, is a very important concept. And let's just look at it a little bit. Just to try to really get the meaning of what tends to means. So if it says a function f of x is equal to x plus 13, the same one we used in the beginning. If x tends to 17, what does f of x tend to? In that sense, you could think of it as, if something is really close to 17, what is the value of f of x? So for example, if x is equal to 16.999 and 16.999 gives you the value of 29.999. The same thing that if you take an even closer value to 17, 16 point followed by 9 nines, then you'll get the answer of 29 point followed by 9 nines. If you choose the other way around, where if you take 17 point and then 0.00001, you'd get the answer that is almost 30. In that sense, you could say that when x tends to something close to 17, when x tends to 17, f of x, it tends to 30. This is the basic fundamental principle that is about limits. Now, if you truly understand that if x tends to 17 and f of x tends to 30, then you could also put it mathematically as the following expression. X plus 13 is equal to 30 when x tends to 17. That's how you'd read it. If you truly understood this, then all the problems from our exercise also distill this way to limits. 3x plus 9 is equal to 18 when x tends to 3, sine square x plus cos square x is equal to 1 when x tends to pi, so on and so forth. Now, these are all representations of the same functions with limits. Now, at this point, I do expect a question from the viewer. Well, that does seem very obvious. Where's the math in it? Where's the complexity in it? And so far we haven't touched on it because all these functions are rather easier put. But to truly understand where limits become critical, consider the following function, sine x by x. Now, when x tends to 0, what would be the value of this function? Take a moment and take a guess about what the value could possibly be. Now, to really get the idea of this having any value, you have to first substitute the value in. If you put 0 in, you get sine 0 by 0, and then you're in trouble because the expression is divided by 0 and we don't have an answer to that question. Anything divided by 0 is just not determinable, and suddenly we're in trouble. But based on our previous trick, let's have x tend to 0. And what I mean by that is, let's you look at the same example, and I'd like you to take your calculator and put this value in, sine x by x when x equals to 0.1. Please do note that the value of x is in radians and not degrees.